looking at implicit differentiation. In calculus 1, we've dealt with two variables, x and y. We want to look at implicit differentiation for multiple variables. But before we do that, we have some questions here. We have three variables here. Also, we have three variables here. Okay. So, want to quickly recap what we said in calculus 1 with just simple illustration, simple example for x and y variable. Okay. Then we now go to multiple, more than two variables. So, what we said in calculus 1, we said that when you have two variables, you differentiate implicit differentiation. That will be differentiate what? Implicitly, okay, with respect to x. So we now have this one, if we differentiate respect to x, I've explained how to do this one. You're going to differentiate respect to its function, and then you put dy dx by the side. Okay, so this will be 15y4 dy dx. Then this one will be equal to what? 7x6 equal to 5. Then you can make this one to be here, move this one to the other side. So we have 15y4 dy dx equal to 5 minus 7x6. Okay, so dy dx is equal to 5 minus 7x6 all over 15y4. So that's what we have for x and y. Okay, but we want to look at different case where we have multiple variables. And look at the question we have here. Find del z, del x, and del z, del y for each of the following. If you check the first one, we're going to look at the first one. The first one, since we are told to differentiate partially with respect to x function, so you do that. Differentiate implicitly with respect to x. So, and what this means is that if you look at what we are doing here, this is respect to x, this is respect to y. Okay, that means when you are focusing on respect to partial derivative respect to x, okay, y will be kept as what? As constant, and vice versa. Okay, so in this case now, this will be equal to what? I'm going to differentiate this one, 3x squared. If you differentiate this one, 3 will go to the front. Don't forget the rules of differentiation. When you have this, the dx of this, okay, and that will be, this 3 will go to the front. So we have 3 x to power 3 minus 1. Okay, so that's that. Then you keep this one constant. Okay, it's a product rule. Then plus this one constant and differentiate this one. So I'm going to keep this one constant. I'm going to differentiate this one, which is what? 2z, and that will be what? Del z del x. Okay, that's the implicit differentiation, because it's also a function also. Okay, so then minus, actually we have two functions that is differentiable. We have this one, we have this one. This one is a constant. This is a constant, so I'm going to differentiate this function, which is 1, and keep this one constant, plus. And you keep your x constant now and differentiate your z. So that will be, you keep this one constant and differentiate your z. That will be del z del what? Del x equal to, this will be 2x. This is what? This is y. This is what? That's the x. Let's bring them together. But before that, do the expansion. We now have equal to, here we have 2x. So bring other variable to other side. So minus 3x squared z plus 5y cube z. So finally we have del z del x equal to this one. Then let's get the del 0 del y. So what we are going to do now for that same equation, we're going to differentiate both sides implicitly respect to y. When you are doing partial derivative respect to y, x will be kept as a constant. Keep this one, your x variable, as a constant. Okay, so here, this one is a constant. Keep it as a constant. You differentiate this one, that'll be 2z. Okay, del z del y. So I'm done with that. Come back here also, 5x as a constant. I'm differentiating y to power 5 and z. Okay, open your brackets. So differentiate this one. That's a product rule. That'll be 5 y to power 4, while you keep your z as a constant. Okay, then plus. Can you now keep your y now as a constant and differentiate your z? That'll be del 0 del y equal to. Differentiate this one, that'll be 0 plus. This will be what? 3y squared. So open the brackets. So let's bring the del z del y together. I mean, then we have this equal to, move this one to other side, plus what? Plus 3y squared. So finally, del z del y will be equal to this. So that's that on the a parts. So we've gotten del z del x, and we've gotten del z del y for the a parts.